Hi guys, hello everyone. Welcome to another episode of Everything Products, and today we are going to discuss AI automation in telecom. We all had a phenomenal journey in telecom, and we at GS Lab Gas have been fortunate enough to be the carriers of the journey from the technological perspective. And as software engineers and architects, we learn these complex specifications and converted those into network functions. We wrote tools to test this network functions, and we've also looked into the operations and how to monitor those and found faults, rectify those, and so on. We had our challenges. We handled those in the human capacity. And now that AI is here, AI is talk of the town. We want to see, okay, how AI can help us here, and that is the main topic that we want to discuss today. And thus, my name is Ganesh Samant. I am going to moderate this webinar. I'm closely associated with this 4G 5G journey at GS Lab Gas, and our main speaker today, Sagar, who has 20 plus years of experience in building this network and telecom products. He has hands-on experience on these technologies from QA automation and operations and DevOps perspective. The rest of the session, he's the one who is going to do most of the talking. But before we venture into this main topic, I would like to know your opinion on something. And let's have a quick poll. You have 30 seconds. So I'll wait for you to answer the poll. So what do you think? The scale of the devices connected to 5G and by 2030 as compared to 2023, it's today, like 5 times, 10 times. We'll soon have the answers. All right. So 50% of the audience thinks it's going to be 50 plus times, and that's the answer that some of the independent analysts are agreeing on. This can be even 60x, and this just phenomenal scale. I mean, the scale at which the expectation from the operations are like huge, and it just say a few 7 years from now. So Sagar, I will hand it over to Sagar now to just talk about how do we address this challenges in operations and as well as other practices in the development of telecom. Sagar, over to you.
Sure. Thank you, Ganesh, for having me here. Yes, this is a enormous scale that we will be expecting 50 plus or 60 times of devices synthetic by 2030. So, which is an enormous scale. But then, if you have to look at today's view, today the telecom networks that we see are already complex networks. There are many network functions and the messages between them. It takes considerable amount of time and the human energy to deploy and maintain the telecom networks. So it is an imperative thing that we need to try and think about solving these problems, and that's why we are meeting here. That we need to really see if we can really use the AI tools and AI tools into telecom, and then make it AI centric telecom. So I'll be talking about 3 aspects of QA automation, operations, and DevOps automation. So as we talked about that, the things are complex here, right? But in spite of that, we are having the support calls banging onto the doors of NOC, thinking about, the things are not simply working. The more the complex network, the more problems and the more humans and the times. So if we just took the number of devices going to get connected by 2030, it's huge. So we need to find these solutions, and we have been finding ways to go through these challenges by inventing new tools, tool chains, etc., and even making the fundamental research in technology and architectures, for example, like 4G to 5G. This is on one hand. On the other hand, AI has its own journey. AI has always been a fantastic or fascinating topic. Movies have certainly made it larger than life, or maybe like an advanced alien. However, recently the ChatGPT has shown us that the AI has come to our doorsteps as a real usable platform. It has come to foray of everything. Now telecom world is trying to see how it can be really used. But I feel that we need to be really careful in adoption by differentiating between what is really the hype and the ground situation. So my focus for today will be these three topics: QA automation, DevOps, and operations. And let's explore how AI can solve the traditional and the modern challenges of the telecom automation.
Oh, that's a nice start. Thanks, Sagar. By the way, audience can ask questions anytime. Feel free to post the questions. We'll take those. And based on that, will be, of course, there will be a Q&A session at the end. But feel free to ask questions as we move on. Yes,
Sure,
sir.
yeah. Thank you. Let's talk QA telecom automation. Traditionally, the QA automation has its own journey. The whole human-centric QA activities has sufficiently matured over the period of time with the tools, tool chains, frameworks, etc. But telecom QA is different and it is difficult than the traditional QA. That is why we call them as TEDT, which is test engineers in DevOps and Telecom. That's may not be the standard term as such, but that is what we call it here. And there is a reason that why we call it here, because these things involves dealing with complex architectures as the number of network functions and there are multiple instances of them. There are myriad protocols: diameter, NGAP, GTP v2, ICA-KMP, PFCP, etc. The infrastructure is complex and there are interdependencies between them too. Proliferation of independently developed network functions to work in tandem with the other network functions. So these all factors really, make it very, very complex. And that's why this telecom QA is different than the traditional QA. If we talk about the automation, writing the QA automation test involves reading long specification documents and interpreting them into test cases and then automating it. Just as an example, just one positive UV attached test case, there are 20 plus messages exchanged between the different network functions and the 4G core in 4G core. So it is fairly complex. In situations like this, we normally tend to see if there are any automation tools or the frameworks that are available. Well, it is getting some traction. SIM banks, RAN testers, call flow simulators are there, but many of them are not widely adopted because there are reasons behind it. They are either complex or has interop issues or need some customizations there. Plus, there are training needs for to understand them and then use those tools too. So we invest a huge amount of time and energy on humans for a domain understanding, tool understandings, B tool understanding, and C new technological advancements. So this is very human driven. Though the use of generic automation tools like tool chains and the frameworks like Jenkins, PyTest, Python, Postman, robot frameworks, etc., and a new technological advancements like cloud have reduced the human effort significantly, but now it is demanding high-skilled humans. In addition, we deal with problems like human error and human retentions. So the challenges that we have today are these. The human efforts have reduced, but we need more skilled humans. Any updates into the technology needs human efforts to update the automation. Custom integrations need human interventions. Domain specific knowledge is a key paramount. And we need to really see if AI can really solve these challenges. However, let me talk about the challenges in the other two areas as well.
And by that you mean DevOps and operations, right?
Yes, by that I mean DevOps and operations. So let's start with DevOps. DevOps too started with human-centric approach of IT management. The team then either had built their own custom solutions or there were companies building the solutions for them. Then there were some of the tools and the tool chains were getting available from the data centers too, as a part of being with them or from the companies that they are using the hardware of. This was all pre-cloud era, where we were focused on macro view of the things with max uptime of say 99%. But but it has its own problems. This did came with less customizations and feedback cycle was slow. The network was static, closed, and dominated by vendors. Then came the interesting part, which is cloud. The cloud kind of changed the landscape for telecom. The telecom systems were getting installed onto the COTS hardware. The networks are dynamic, open as compared to the previous ones, and with abstraction layers added to the top of the things, helping ease of the deployments and the maintenance. But with cloud, the expectations of scalability and interoperability increase tremendously. Now we are talking about 5 nines uptimes, macro view of the things, micro view of the things, the customizations and flexibility got introduced. This all resulted into increased automation. If you see, like using the tools like Ansible, Chef class of tools, Kubernetes, Keda, Nefio. By the way, this Nefio tool is currently being explored by our team. Then came the big giants like Google, Microsoft, and AWS, which have their own tools now. AON, TNA, TNB, which is like telecom network builder from Amazon, which helps in deployment and managing the telecom networks.
So you are talking about the specific. Now we are getting into telecom specific things into DevOps.
Yes, that's true. But even if we have these tools, right? If we see the networks are still complex, there are different network functions. A number of different network functions needs to come together for one UE to get attached, involving many messages and the different protocols. There is a need for deep packet inspection.
Yeah.
Network size itself can add the complexity, right? So all of these are demanding high human skills, as deployment is still a significant task. Furthermore, with the 5G, the introduction of NWDAF have made the large data available. This data, if used wisely, can do wonders with increased automation again. Can AI help in solving these problems of complex networks, high-skilled humans, and handling large data generated efficiently and effectively? We need to see. But now we also need to see the third area.
The operations. Yeah, right. And we are still pre-AI. We are talking about all this pre-AI stuff. Yeah.
Pre-AI. We are just trying to identify the current situations and the problems into it, right?
Yeah.
So now the next area, as I said, the operations. The basic aim of the operation is to keeping things up and running, right? The traditional problems of operations such as high availability are solved by DevOps, but scalability increases multifold when we talk about operations. And beyond that, operation has its own challenges, such as ensuring that the business SLAs are met, generation of call data records, accuracy of call data records,
yeah,
detection of anomalies, network congestions, data migrations, customer support, backend officers, and many more. But in addition to that, there are requests that came to us to solve the problems that the operations SRC team was facing. The team was handling multiple application services and wanted to find out the dependencies among them, the REST API calls those services were making, how these services are interconnected, and whether they are lagging or not. So we have also seen aberration issues in the production, where 1 in 10,000 users is seen to have issues in accessing the services.
Yeah,
it's a challenge to look into the huge data of production PCAPs, locate and isolate the user and its user and the time corresponding to the issue. Do the protocol analysis, deep packet inspection, and then alert. So there are problems that needs high human involvement. All these operation challenges are time bound and affect the ROI. So can AI solve these problems? That's something that we need to find out.
Okay, great, Sagar. Yeah, before you go into the AI, I have another poll, the audience.
Sure.
And can we go to the poll? So we have the poll. How much of a kind of average time does one need? Does an engineer need to become this TEDT, test engineer, DevOps, and telecom? So we are not talking about just niche or general purpose DevOps tools here or QA tools. Someone who can actually do telecom can do it well to some extent. Is it going to be 6 months, 1 year, 2 years, 3 years? I'd like to know what do you think? I'll wait for the answer. Yeah. A few more seconds. Okay. All right, 6 months. Okay, I'll tell you what, we got 0% for 2 years, and in our experience, it's definitely around 2 years or more. It's in 6 months. It's too little a time for someone to get acquainted with the tools and the tool chain of this AI. As sheer weight of knowing right from operating systems, networking, plus this different specifications, all these services working in tandem, and to make a meaning out of it, and then to find, okay, how do I actually write a test that can walk me through this, or how can I, if there is a problem, how do I isolate the problem? This is 2 years plus, and that may surprise you, but that's what we observe here in our, and that's quite a long time. That's quite a long time, and that's why we are talking about, oh, can AI help us here? Can it do it quickly? So Sagar, please go ahead on your discussion on this AI.
Sure. Yeah. So our experience normally tells us about there are 2 to 2.5 years that it takes for an engineer to be, sort of working properly into the telecom, right? But I just want to add one more point to that the question that you asked here, right? Because see, what we have seen is that the telecom team or the telecom people are always being getting reskilled every now and then. Allow me to explain. Earlier, there were circuit switching. The telecom team were trained on circuit switching, then came the packet switching, telecom team got trained on the packet switching, then there were architectural changes, protocol updates, and now they have cloud. So it's a huge task to reskill the entire team. And then if you see the same telecom team is getting reskilled every now and then at a regular point in the interval. So it is a huge time. Anyways, yeah, that's just an addition to what you asked. So let me continue. Yeah, let me continue with the topic here. Right, so let's look at how AI can help us increase the areas and move from left side to the right side with the power of AI. Let's talk about QA automation. In the past, there have been attempts to convert the good old 3GPP specifications into YANG model and then use it to generate the code out of it. 5G made it simpler. 5G re-architected with service-based architecture. 5G specifications are available as an open API specification documents. An AI engine that can read the open API specification documents and generate the tests to validate these APIs, not only from the functional perspective, but also from the non-functional perspective, like load testing, then it would be really great. Moreover, the AI engine should be capable to generate the telecom specific test cases like context-driven call flow verification, and also should do the deep packets inspection as we talked in the previous slides. AI should regenerate the code when the specification changes or when there is a change in the specifications. So there is a clearly reduction in the human efforts and saving the time and money here. Okay? Let's talk about the other aspects of DevOps automation. Now, with the things like ChatGPT, it has shown us that what is possible, and almost everybody is talking about AI. The most visible winner here in AI is clearly the interface of plain and simple natural language like English. So what it is actually adding a layer above the layer to make the things easier to the user of the underlying layer. More mature NLP models, when trained appropriately, shall have the context along with the keywords. We are going to see a lot of buzz around this, where there will be abstraction layers added on the top of the current layers to fast roll out the AI-enabled engines. Let me give you an example. Suppose setting up a DHCP IP address range for a DHCP server. We could simply say that set the DHCP server to serve the IPs in the class C range, or configure the routers to serve the BGP. The expectations here would be this should work irrespective of the make and model of the router, as long as it has inherent support to do so. So AI will deploy the telecom specific deployments through natural language and make it ready for the testing and operations.
Mhm.
For example, let me talk a telecom specific example here. So for example, the instructions can be deploy latest free 5G-C without UDM on a fresh VM, use SMF01 as SMF of telecom core, okay, verify the network connectivity, provision the core with IMSI details one. So
So
the
this is now telecom specific things that we get,
yes,
because we
yes,
are talking the language of niche. This so far telecom DevOps nerds and how they want to do things, and it's talking all the telecom language here, and it understands it. That's the expectation now.
right, exactly. That's the expectation. So all of this is going to save time and huge efforts for us, right? The person here shall not need to, shall need to know what he or she wants and the architectural view of the things, but doesn't really need to know the specific commands to get the things done.
Yeah.
Right.
Right.
So operation assistance, let's talk about the operation assistance because it is going to be more helpful here too. Ultimately, the AI will help us to address two main objectives of operations, that is minimum disruptions with maximum service availability. To begin with, AI shall be able to understand the complex mesh of network or telecom services and the network topology. It should then monitor the health and the SLAs. These are the basic expectations.
Yeah, the basic ones that everyone expects now. It should be beyond that now.
Exactly. So, however, we expect the AI to also do a deep packet inspection and detect the anomalies which are hard to simulate in the controlled environment. It should pinpoint the fault areas in the rapid time. With maturity, AI should be able to even predict the future failures. Remember, these challenges here is to find, the challenge here is to find the needle in the haystack, right? Because everything is operational, there are multiple users, everything is in the production, right? In real time, AI has to walk through the huge amount of data and learn from it.
Yes, yes.
Right. However, the current AI engines are not mature enough to really get us the end-to-end experience that we just talked about. One way to help this transition is to create intermediary tool and domain-specific language to assist and take the and help and assist the AI to take this leap. We have Octopus tool helping in doing that. Let me just talk about an Octopus before we talk about the future. So creating an intermediary tool chain and the domain specific language to assist the AI to take the leap that we talked about is the crux of the matter.
Yeah.
We at GS Lab have a homegrown tool wherein we have invented a DSL and an engine to execute that DSL that assists us in QA, DevOps, and operation challenges.
Yeah.
Octopus does this in collaboration with third-party tools, tool chains as well. And we have used Octopus in production environments through different MVNOs to detect and report the anomalies besides testing the telecom core in the lab. In other words,
yeah. So we have some kind of interpreter sitting here who understand one language and telling the others, okay, you take this language and you understand. I can do the language translation, so you can learn quickly.
Right. Let me summarize it for you. What we are saying is that in a way we have abstracted the specifications into DSL.
Yeah.
Now the engineer has a simpler language to deal with.
Yeah.
And because now this is a simpler language, AI can now also leverage this very quicker.
Right. Yeah. I understand.
In my opinion, we need such tools now until the AI completely takes over. So with that in mind, let's look into what the future will look like.
Okay.
Open source telecom AI. So with 4G, we have seen that the telecom cores are getting open sourced and getting installed onto the COTS hardware. The Open RAN is making progress too. We already have open source 5G core in terms of free 5G-C and open 5Gs. So there will be time in the distant future where we may have an open source telecom specific AI. Just think about it. People adopting it does not need to write the AI engine from scratch. The AI engine will learn based on the traffic it is getting. this will be available out of the box with the open source telecom core and start learning from day one. This will be an autonomous system that will train itself and start functioning on its own. This again will boost the savings into the human efforts. And if needed, we can add the customizations or do some additions into the base open source AI. Right? The next is the explainable AI, and this is favorite. This is my favorite, because as the AI is in the limelight and many companies are coming up with their own AI engines, there will be times when it will hit the news of news saying AI acting weirdly and not taking the decisions that it should take, and AI is not working, not good, and things like that. But from the technologist point of view, if we say this is just a transition, and as the technology gets mature, these issues will be weathered out. But this process can be very well monitored and guided by with the explainable AI. The governance policies can also consider the reasoning part as a mandatory, making the AI engine developers to write the reasoning behind the decisions. So, and in production,
so you're holding them responsible. They don't just take decisions. You tell us why you took decisions. So
exactly,
you want to know.
Yeah, exactly. And this is multifold, Ganesh, if we see that, right? Because in production for critical applications, this can be thought about being written on a non-alterable systems like Hyperledger. That is coming from the blockchain technologies. Then it can make it can make a difference in the critical applications. People can start trusting the AI then, and then these reasoning or the why part of it can be really used to train the AI models efficiently.
Right, yeah.
For telecom, the networks are complex. If we add IoT to it, it would make it even complex.
Yes.
And in that case, operations perspective, if AI could write the reasons behind the decisions and the behavior, it will be very handy for the operations teams, and they can focus only on the critical and customer related issues.
Right.
This reduces the time and human effort significantly.
Yeah.
Yep. I have one more for you. Distributed AI. UE, from UE, RAN, and core, there are multiple places where there can be AI. It may soon happen that these components may have their own AI focused on their own core functionality, but may be able to talk to each other, and together it will result into better customer experience. Let me give you an example. Based on the previous user's pattern of the user, or the current application that he or she is using, based on the direction that the user or the UE is moving, and based on the current traffic load of the destination UPF or the RAN, together the system may decide to allocate more bandwidth momentarily so that the media that the user is consuming may get downloaded or buffered, and she does not experiences the glitches when move to the supposed to be loaded UPF or RAN. See, the system will really work intelligently.
Okay, so we are talking about future now. You spoke about this last 3 points mainly about the future. Okay.
Yes.
Right.
Yeah. Okay. That's true. Yeah. So in conclusion, what are we trying here? What are we saying here is, we have to think AI first, because the network scale is growing, the human training costs are more. So whenever there are applications that we are considering to be developed, to be added functionalities to, we need to think AI first. The QA automation, as we talked about, will definitely will be AI enabled in distant future, but it will go through the routes of DSL, which is domain specific language. AI right now, with respect to the maturities of the automations, or with the DevOps automations, and as it is very close to get enhanced with the AI, and it will need a little help from the DSL perspective. However, operations would also go into the way that we discussed about the QA automation, that it would need some sort of a DSL to really work with there. Then there comes, once the DSL part is over, it will not need, the AI will be really matured. So it will not really need the DSL there, but it will directly read from the specifications, will use the NLP to manage the automation deployments and operations, resulting into completely autonomous networks. The overall journey here is from if you say humans with niche skills to humans with general purpose skills. And I believe that's what we are heading.
Yeah, I can imagine that. You don't want to give very detailed technical answer. You just instructions to do something.
Yeah,
Yeah.
that's true.
Okay.
Yeah.
Good. Yeah. Now it's open for Q&A. I think that's where we are. Before Sagar concludes, do you have any questions? I'll give you a few seconds to answer. Ask questions. Okay, Sagar, we have our first question, and it says the scalability and reliability is already solved by cloud company. Already it's done. So I know that you have touched that topic. It's already solved. What is left to solve in AI?
Oh, wow, that's a great question. So even if this is kind of solved by the cloud companies right now, but let's understand how it has been solved and what is needed there. We need a high skilled humans there. The reskilling of high skilled humans is a task there. Scalability is an issue when it is too big, and then the low level anomalies, the packet inspection and other things. So that's still there. So we have used this, our experience of putting the telecom core in the cloud I mean, it took us for more than 2 months, and the issues were very low level networking and interoperability issues where, it took experts from both the sides, from
So
the
in spite
BSS.
of having cloud readiness and in spite of we having all this Kubernetes and everything ready, the telecom core still took 2 months to actually get to a level where it can be used in the deployment.
Yes, that's true. So at least now it doesn't seem to be ready as it seems to be.
Okay.
Yeah.
I hope that answered the question. We have another question here. Yeah, it reads, what will humans do in AI operated telecom? This is a scary question, usually put by Luddites, and that's an interesting question. And how will you address this?
Right, and that's a good question. I mean, if we are talking about everything automated, and with that's a normal question that everybody would come to see that what would humans do? Well, in my opinion, the humans will still be needed in a smaller numbers. Okay, and mostly it will be a general purpose skills as we talked about. There shall be, however, very few humans will be needed with a very high skilled skills basically.
Okay, so it's all about scalability. Actually, humans will niche skills will be less required. There will be few, but there will be a lot of people with general purpose skills who will be managing this. You don't have to spend too much on the skilling and reskilling.
Right.
Yeah, to some extent. Yeah, I hope that answers that question. If there is any other question, okay. All right. Yeah, I'm still getting this. Okay. So this is the question is how AI helps manual testing. AI is not clever than human beings. Then why is everyone going for AI?
Yeah, that's true. It is not clever than human beings. That is very true. But that is the model. I mean, that's the crux of it. The model is getting trained based on the experiences and as based on the data that it has been fed to, and that is how the beauty of the AI is, and that is how it is being trained, and that is how it will take the decisions.
Okay. All right. I have another question that says. It's more from the security perspective. We didn't touch on that part. What are the security side challenges towards using open LLMs?
Yes, definitely. There will be challenges on using the open LLMs, especially if you don't have access to it with respect to what it is doing and how it is doing. So that needs to be really thought through, and that needs to be included into the governance policies.
All right, and we are still at nascent stage to answer that question also, I believe.
Yep.
And there's one more question here which says how to safely integrate. Again, it's all safety, but I think by safely it means with certain security. How to safely integrate AI algorithms infused in operational practices within infrastructure and transferable to telecom related services side and measure it. So it's bigger than just that. So there is a safety aspect. How do we safely integrate AI algorithms, infuse into those into operational practices, and transfer to within the specific infrastructure and transferable to telecom related services. That's so there are multiple things here. We have operations and telecom services and safety of integrating AI algorithms into these operations.
Right.
So
yeah. So here, I mean, there is no fixed answer to this, as I understand, because we are talking about multiple things out here, telecoms and then the operational practices and other things. So it can always be, you know, a few places where the first sample or small engines of the AIs would be tried out, and then once that gets matured, the scope would be extended to it.
Yeah, and we still need to look into that path of how actually trying out in lab and how to see how to, before even talk about safety in operations. We still need to try this and learn from it. Yeah, I think that's all the questions I have so far. Yeah, we'll give a few seconds for others to ask any other question if they still have any. A few more seconds. All right, great. I think that concludes the webinar. Thank you, Sagar, for taking us through this journey, sharing your thoughts. Thank you everyone for attending. And I think that should be it. Thank you very much, and please do attend our next series of webinars in Everything Product. Thank you.
Thank you. Thank you. Thank you, Ganesh, for having me here.
Bye.